That's the end of that. Hello, folks.
Hey guys.
Welcome to Rational Science. We're here with my son Hans. We're going to talk about the muon today, whatever that is.
Why are we talking about the muon?
I think it reminds me of cows, like whatever. Anyways, let's get in there with a little bit of extinction.
What?
Extinction.
What happened to the muon?
That's coming later.
Oh shit.
And what is extinction? Extinction in this channel, right? What we say is that we are likely, very likely, the last generation of humans on Earth. It all ends here, okay? And I've been talking lately about a very popular topic, which is recession. We have a recession coming up. And here's a bit of news on that. Okay, it says Market Watch, we see major stock markets plunging 25% from levels somewhat above today's. That's by the Deutsche Bank. And they say that, United States is expected to go into a recession by mid-2023. So if you've got something better to do, well, don't do it. Wait for mid-2023. Maybe it comes sooner. Maybe you don't have to wait that long. Here's a TikToker who apparently got some people riled up because he suggested that also recession's coming around, and more than 1 million people locked into him. And here it is. Says he said, "You should be terrified." A TikToker went viral for explaining why anyone in the U.S. making less than $25 an hour is in serious trouble. Okay, and the reporter, the person who wrote the piece says, it's time to be scared when a TikToker says so. And so what does this person say? He says, well, recession looks more and more likely, lasting through most of 2023. Inflation is rising, along with interest rates, and more Americans continue to find themselves in dire financial straits. And he goes on making an analysis of regular expenses, and he totaled them to about $3,300 per month. He says that you would need a minimum of $20.50, almost $21 per hour, and if you add taxes and other expenses, that would reach somewhere around $25. And so he said you have to increase your income. It's a must. Real average hourly earnings fell 2.8% from October 2021. Unemployment is up 3.7% for October. And he says working side hustles isn't going to create enough income. It's going to have to be what? Investing. You're going to have to invest your money. Probably in Bitcoin, probably in some stock market money or whatever. Somewhere you're going to have to invest. And there's people who oppose what this fellow says, but even these are the suggestions counter suggestion, I guess you could say, they proposed to him. Find at least one roommate to cut costs in half, or sell that car that you can't afford. These are simply periods in your life that you need to get through on your path to what? Financial freedom, right? And I like that final note that these people said. It says, this is a season of your life, but it's not a life sentence.
I like that term, financial freedom, that gets thrown around a lot.
Well, I was focusing more on what these people said. It's not a life sentence, meaning, is the recession forever, or will we come back? That's the issue. It's going to last a while. The question is, will we come back, or up if you wish, or will we go down into something worse like depression?
Aren't they professionally obligated to say that it will come back?
Well, it's good for morale.
That's what I'm saying. Who is going to go out and be like, no, we're all going to die?
Me.
But yeah, exactly.
I'm not a pessimist, okay? Yeah, I'm just a realist.
Yeah. That's what pessimists say.
Okay, and so this is what the markets, another note out there, another bit of information says many investors are betting on inflation peak. In other words, that we're coming back. Here's why a former hedge fund manager says they're wrong. Okay, and what he says essentially is that investors are investing in long dated bonds, and you can see there at the bottom it says long-term rates of interest drop beneath brief time period charges. In other words, he's saying that the investors are investing in bonds, long-term bonds, and that suggests that at least either they're playing safe or that they actually believe that the recession is going to last a long time. It's going to last a little longer than 2023 because some of these people are talking about at least 2-year bonds making it past 2024. So you may have to be ready for a long-term recession, okay? And another bit of news that kind of points in that direction or shows that we have some kind of problem, partly because of this war in Ukraine, is that the Russians are now changing dollars for yuans. Okay, so the Chinese are happy. They're saying, "Hey, we're going from the greenback to the redback." Okay, and so keep that in mind that a lot of stuff is changing in the world, and it may not favor the West. It's just a wait and see and find out what happens in the future. But right now we have recession coming around. We have oil problems, energy problems, and we have major shuffles in the world economy, like Russia and some other countries going into BRICS, another coin there, and
called
yuan.
BRICS?
Yeah, BRI because they're called BRICS because it's Brazil, Russia, what is
Oh,
it?
yeah, yeah, yeah. It
India.
just sounds like a funny currency.
Yeah, it's the
How many bricks do
initial.
you have?
Yeah, it's the initials of every country there that is a member. Anyways, these are the possibilities as far as I'm concerned. Okay, we go from recession to depression and maybe to extinction. Okay, the question is whether this is the last recession. Okay, but for that we need to understand what a recession is. The definition we find is negative economic growth for 2 consecutive quarters. Now that's a definition that the British have, and it's also an old definition that economists in the U.S. had. Today they don't want to put numbers to that, like time frames. So this 2 consecutive quarters is an informal definition. The formal definition is just negative economic growth without specifying for how long. The issue is that when you look at depression, which is the next step if things get worse, it's defined as a steep and sustained drop in economic activity featuring high unemployment and negative GDP growth. In other words, they haven't said anything new. It's the same thing as a recession. One thinks of a depression as longer and steeper. That's all. That's the only difference. But other than that, there's really no difference between these 2 definitions. And again, they may not want to define them perfectly well because it might discourage people.
Do they
Anyways,
even use the word depression anymore?
well, no, because
They
it
tend to
hasn't
stay away from that one.
it hasn't happened in a long time.
Yeah, but I mean, even if a recession lasted 2 years, they wouldn't call it a depression just out of professional courtesy.
Or
It's
just
not a depression. You're just going into denial.
Just a long recession.
Yeah, really long recession. That's all it is.
Anyways, we look at background extinction. What is it? I say, these are my definition there: the dying out of a species, and mass extinction, the disappearance of a food chain. And the question is whether we're going to disappear with this collapse of the global economy, which is what I think is going to happen. Okay, that's my theory. Okay. And based on the fact that all species in the past that died in a mass extinction died when the economy collapsed. And I don't see any difference now for humans. And that's something we can't do much about.
We got brains though.
Oh yeah, but not brains enough to fix the economy. I can't fix it. Anyways, one fellow put a comment, says, the economy is going to burn. Don't you think it's a bit artificially contrived? In other words, he's saying whether the people upstairs, the um, Illuminati, the New World Order folks, the people who run the world, the people who have money and influence, are they planning something? Is this being masterminded or something? Without lockdown policies and green policies and Klaus Schwab shenanigans, I don't see how the eradication of global extreme poverty would be reversing. I don't see it reversing either. So, I'm in the same boat as you are. I can't imagine how we can turn this around. Okay, I'm not sure what we can do to solve it. Okay? So what I look at is mass extinction, and the question there is that nobody has really defined the term mass extinction or background extinction for that matter. Here are the definitions you find out there for mass extinction. This comes from the Wikipedia.
Did they define those yet?
Yeah, no, they didn't. You'll see in a minute here. Mass extinction, also known as extinction event or biotic crisis, a widespread and rapid decrease in the biodiversity on Earth. Is that what an extinction is? A decrease in biodiversity?
That's one way to put it.
It's not. I mean, hopefully extinction means someone disappeared completely, not that there's a decrease.
Yeah, a decrease in biodiversity. There's one less diversity.
No, because we're talking about mass extinction.
Yeah.
So mass involves many. We're not talking about one species.
Well, still, the definition still applies. Decrease in biodiversity. There's less differences.
I disagree with you, my dear son. Anyways, such an event is identified by a sharp change in the diversity and abundance of multicellular organisms. It occurs when the rate of extinction increases with respect to the background extinction rate and the rate of speciation. These people talk about rates. Okay, it sounds like mathematicians talking and not about paleontologists, which are supposed to be qualitative. They're supposed to tell us what an extinction is and how it happens. And these people are defining things, as far as I'm concerned, where it doesn't address extinction. I mean, the dinosaurs are not around anymore. Was that because there was a decrease in biodiversity, or is it because they disappeared completely? They died.
It's binary. Is there still one T-Rex walking around or not?
So I call mass extinction the disappearance of a food chain. That's the mass, right? Background would be the disappearance of one species. Okay. Anyways, you can see here that right at the bottom there, just look at one example, Cretaceous there, about 145 to 65 million years ago. Dinosaurs are no longer around, and I'm saying that the definition that we have, the official definition, decrease in biodiversity, does not address what happened exactly at or somewhere around 65 million years ago. Yeah, if we're talking about decrease in speciation, if we're talking about decrease in quantity, that happened in the last maybe million years or more of the Cretaceous. So it's not like everything died on one day. It's like it slowly decreased until the decrease was incremental, was exponential, and then they finally were wiped out. Hopefully we talk about extinction has to be defined in such a way that we address the fact that some species are no longer around, and not just saying, oh, it's a decrease in speciation or quantity or whatever.
Yeah, I'm wondering why they define it so vaguely. Like, what fringe cases did they have to include in that definition?
Well, here
you think it's clear cut.
Maybe
when
the next one.
Oh, I know why. One reason might be because it's hard to tell where one species ends and the next one begins. So they have to say loss in biodiversity. They can't just say when the last dinosaur or when the last T-Rex dies, because then there's T-Rex A and T-Rex B, and they're like close to each other. But when do you say the last one died? Because this one that looks kind of like him might still be walking around.
Well, again, you wouldn't say that any dinosaurs survived beyond around 65 million years ago. There must have been one last dinosaur sometime in the history of Earth. We don't know who that guy was, but there had to be that situation.
But again, they might be saying like some of those dinosaurs just turned into newer species.
No, but that's
that kind of stuff.
Yeah.
But that's what I'm saying. They had to define it in such a all-encompassing way They can't just say when a species ends, because
Well,
where does one species end and the next one begin?
Well, I think it's very clear. We don't have any mammal-like reptiles from the Permian here. We don't have any archosaurs from the Triassic. We don't have any dinosaurs from either the Jurassic or the Cretaceous. And we're not only talking about these animals, which are very more or less familiar to us. We're looking at also the plants. You know, the plants that died, they disappeared. They're no longer around. So I think when we talk about extinction, we can't just talk about, oh, it's a gradual process where there's a decrease in diversity or quantity. You have to go and say, look, it's the disappearance of something. That's an extinction.
Yeah, okay, but they also go back in time and study it like frame by frame. So for that time, they weren't extinct yet. You know, here today we can say they're all extinct.
Right.
That's easy, but they're also looking at it with the eyes of the past, where if you're looking at it from the Cambrian point, some of them are extinct and some of them aren't extinct yet. But you can't just say all this whole species died because they might have turned into a different one. So did they go extinct, or is it just loss of biodiversity? Like, again, I think they had to define it in very vague terms because of these fringe cases.
But because they did that, they don't zero in on the issue, which is the causes. Because they say, oh, they just continued rolling and they just branched out instead of, you know, maybe a branch of the dinosaurs became the mammals. Maybe that's what they have in the back of their minds, or something along those lines. And so it's like we never talk about extinction because it never happened. It's just it's a continuous evolution. That's more or less the way that some of these people see it.
I think they defined it in a vague way so that they can accommodate any extinction theories.
Also, and it leads to what the problem is. We've never defined what paleontology is. That's where the problem starts. We don't have a definition for paleontology. This is what you'll find out there, okay? Paleontology, the scientific study of ancient life.
That's what I would have said.
Well, first of all, it's not the study of anything. In science, we do not study. Okay, the word study has to be taken out.
That's very apparent to some of our watchers.
Yeah, we don't study.
We don't study. We don't read books.
We don't study. Anybody can study and not understand anything. So studying is not science. Study is what you can do at home, and you can study all you want, but then when you come to the conference, we want a scientific explanation. And the other thing is that paleontologists don't study life. They study the opposite. They study death, if anything. They're supposed to explain how species became extinct. So we don't study life. And you look at the description there, the field seeks information about several aspects of past organisms. Their identity and origin, their environment and evolution, what they can tell us about Earth's organic and inorganic past. That has nothing at all to do with paleontology. Okay, in paleontology, we have to tell the crowd how species died. And here you see at the bottom, that's also from the Wikipedia, it says, gives you an idea of what they think about extinction, or how it happened. It says, when dominance of an ecological niche passes from one group of organisms to another, this is because, they're going to tell us the why, okay, the cause. An extinction event allows a new group to outlive the old and move into its niche. That's not an explanation. That's a description. So they put the word because, like saying, I'm going to tell you the cause, and they're not giving you a cause. They're saying, look, it just, one moved down, the other one moved in. And they're not telling you why, what caused that to happen. And so, again, we don't have explanations for extinction because the definitions, to start out with, are wrong, are irrational, okay? And this is where the problem starts. So what do they think about, what is a paleontologist? Who does paleontology? And here you see the notions that you'll find, again, a lot of this from the Wikipedia gives the idea of what people think a paleontologist is. And it's essentially, you know, if you've seen the movie Raiders of the Lost Ark.
Yeah, I was going to say.
Indiana Jones, that's what people think is a paleontologist. Yeah. You know, he goes with a whip, with a gun, maybe with a shovel and a pick, like, you know, oh yeah, I forgot my pig. It's like that wasn't important, you know. And they have this idea that the guy just hits the rock, pulls a bone out, cleans it out with a brush, gives it a name, assembles the bones, puts it in a museum, and starts collecting entrance fees.
We're done.
That's not a paleontologist. That's a stamp collector. Okay.
What? You mean a bone collector?
No, it's a stamp collector.
It's creepier as a bone collector.
So here it is. This is the notion people have. Okay, this is also from the Wikipedia. You can see here.
This is from the Wikipedia?
Yeah, it shows the first guy, paleontologist at work. No, that's not a paleontologist. That's a boy who's cleaning some bones. That's not a paleontologist. Okay, people think that the guy just goes in there with a pig, cleans some bones, and that's a paleontologist. No, that's not a paleontologist. Paleontologist has to explain something. Otherwise, he's not even a scientist. And the other guy he's preparing some fossilized bones. And then here you have an analysis using engineering techniques show that T-Rex, right, had a devastating bite and raised doubts about its running ability. What's that got to do with paleontology? What's that got to do with who cares if he ran fast? I mean,
care.
You don't have to tell me that he had a great bite. I can see that he had a great bite. I don't need to do any study for that.
Yeah, because he built it, though.
I mean,
I think you're putting down paleontologists a little too much here.
You look at those teeth and you run away. You say, of course that had a great bite. I mean, do we need to make a study for that? No. The issue is, these people think that a paleontologist is an excavator, like Fred Flintstone working in the quarry. This is the idea that people have of what a paleontologist is.
And what is a paleontologist?
Okay, so let's find out what a paleontologist really is. Okay, this is a paleontologist. How did dinosaurs disappear? Okay, science, rational explanation. Paleontology is a branch of science, and what does explain? Explain extinction.
But not just extinctions, also how they lived.
Well, yeah, but I mean...
People are curious about that, too.
Yeah, but how they lived is a description. It's not like an explanation. I mean, if you explain why they live that way, then yeah, that would be...
Saying. You kind of have to backtrack and explain.
But they don't explain. All they do is they describe and they say, oh, this is, it's like...
Well, it's more like theorizing. It must have been like this due to its bone structure.
If they do the due to, yeah. But the problem is there's not enough due to. They don't explain. They just say, oh, this is what we found. We found a bone. We called it this. And it roamed in Africa or wherever. That's what, it's just descriptions. So a paleontologist is a forensic pathologist, a medical examiner who determines the cause of death. That's the primary job, at least, of a paleontologist, and not what these people say, which is just collecting bones and giving them names and assembling them, putting them in a museum.
You're saying a paleontologist is a detective who's really late for the job.
Late for the job.
Yeah, because the detective comes a day after.
Well, but it's
this is a detective who comes a million years later and has to
detectives always come late for the job.
Yeah, but this is like really late. He's like millions of years late. Like, okay, time to solve this crime.
Okay, so
how did this guy die?
these are some of the comments people made regarding extinction. Okay, first, this fellow made this comment first last time around. Okay, and so I'm going to address what he said because he said I didn't address his issue. He said a nation group people can start printing their own new money that will kickstart the economy, and I want to emphasize kickstart the economy. This is what he said. What happens when there is no money? We print them again and start the economy again. Again, I'll emphasize restart, kickstart, and start the economy again. No such monster.
How hard is it to comprehend?
Yeah, so he says, how hard is it?
Why didn't you think of that one?
So he's saying it's all a question of printing new money, and that's no big deal because money is just money, I guess, right? It's no biggie. Money, you can use monopoly money if you want. Okay.
I like this guy.
Yeah. Anyways, and so he says you read only half of my comment and misinterpreted what I meant. I don't say you give free money to all people, and I put that as an example. Only as an example. If money is just money, and you can replace green money with brown money, well, why not, give everybody in the world, every person, $1 million? I mean, if money is just money, what the hell? So I'm not saying that's the solution. I'm saying that so that you can realize that it's nonsense to say that you're going to just replace green money with brown money, and that you can kickstart the global economy. okay, especially the global economy. And I'll get to that in a second.
Are you saying switching one out for the other?
Well, he's
doesn't
saying
change
that
the problem?
this is an easy solution. He says because I'm saying there's going to be an economic
So when
collapse.
the dollar falls enough, they just make a new one and start from clean.
Yeah, he's saying we restart the global economy. In other words, everybody is poor again, starts with zero, right?
That's a clean transition, right?
Yeah,
I want to see that
Bill
day.
Gates is no longer rich, neither is Trump. No one, because we restart the economy. Yeah. We clean everybody's bank account, and we start all over. Now we say no more green money. We start with brown money. And why don't we all restart the process? That's more or less. So I'm focusing on the restart the global economy, and I don't think he's got that context in his brain yet. Okay, this is where the problem is.
It's got a few steps to it, right? It's not just snap your fingers and we got new money.
Okay, so this is the issue. He says printing, nationalized commercial banks, credit, creating credit for endeavors such as. And he names a few endeavors there, okay? Says what Hitler and founding fathers' money differed from dollars, euros, etc., is that they were printed by government national banks. Therefore, interest went back into budget of a nation and not private pockets of vultures. And they created great economies. Well, the first thing I think the founding fathers would not like to be put in the same boat as Hitler. That's the first one. I think they had different ideas. So, you may say, well, they all created new money, and so we can do that again, restarting the economy. And I'm saying this is where the problem is. I'm saying that, first of all, Washington, in the days of Washington, we had an agricultural society. We were still in the agricultural age, okay? Hitler, that was the age of manufacturing. Very different age. Many things had happened in those 150 years. And today we have the age of services. Okay, and even worse, the last 20 years, we've moved into the age of internet jobs, right? So now we have the internet economy, you could say. So history is no blueprint for today. Okay. National and international trade has taken over. International trade has taken over national trade. So we're emphasizing global over local economies. Right now, international trade is more important than national trade. In other words, consumption within a country. And again, it's a fight between macro and micro. And like I said in the past, macro trumps micro every time. It's the anarcho-capitalists who believe in local trade. You trade with your neighbor, get government off your back, no taxes, no rules, let everybody just follow his own interests, etc., etc. It's the old Adam Smith version. Everyone pursuing his own self-interest moves the global economy forward. Well, that's over. Right now it's macro that governs the world, and it's international trade that's more important than trading with your neighbor. And so all I'm saying is also finally there, new money will not erase the debt, ownership of property, create new jobs, erase poverty, or create a world government, which in a way these people are saying, because they're saying remove government, and that's like saying we have no government, which was also, by the way, Marxist thinking. Originally the idea was that anarchism was the goal. And anarchism, not in the bad sense, like throwing bombs, that kind of anarchism. No, what they were saying is, look, the workers take over the means of production. Eventually we have a world government, and then government itself ceases to exist. That was the communist notion. The anarcho-capitalists today have reinvented that in a different way. They're trying to get there, not through communism, but through capitalism, like saying, I'm just going to do my own trading, with my neighbor. But the issue is the money is issued eventually by the government. Even the crypto stuff, all we did was transfer money from existing, from the greenbacks and euros, etc., into crypto. It's not like we created new money out there out of nowhere. The government is still fueling that with just more money that it prints every day. So it's not like we created new money. We have crypto money. It's a new kind of money. Yeah, it is a new kind of money, but it comes from the
It's
old
always
money.
back from the government.
It's not like you're going to wipe out all the money in the world and say, okay, instead of green money or blue money, now we're going to have brown money for everybody.
Does it come down to the faith of the new brown money? Because for example, if all these anarcho-capitalists just invented their own money and they just started trading with that, it would solve all problems, except when someone cheats, then who do you call the cops on for the brown money that the government doesn't even recognize?
Well, they have a solution for that as well, saying that there's private courts like, like town halls in the old days where they could settle things locally without having, a global. But aside from that, to answer the other part, is the question, where does that money come from that you made the trade with your neighbor? It comes from, the government. And it's not backed. People are aware of that. It used to be backed by gold. That's long gone. Now it's after Bretton Woods, it's just whatever value you want to give it. And like you said in your first statement, it's all faith. It's if you have faith in Vietnamese money that you can do something with it, you'll accept Vietnamese money for your car. Not a lot of people will have faith in Vietnamese money, and they will not sell their car for Vietnamese money. And so the question is, money is not money. Yeah. There's money and there's monopoly money.
They're about the same, but more people accept real money than monopoly money.
Yeah, but real money. What is real money? Real money means that you give it value. It could be gold, it could be crypto, it could be whatever you give value to.
Agreed to give it value.
Yeah, but if we lose faith, if we become atheists in money, that's it. Not much there, no value.
In God we trust.
So another fellow says, he says, the human instrumentality project is about human extinction, And he says the project was to have a machine digital record of humanity, so there's proof we existed after we were gone. Proof for whom? I mean, it's like Carl Sagan. He sent this golden record together with a Voyager 1 and also another one in Voyager 2. And that was kind of like a SETI project, the Search for Extraterrestrial Intelligence. And you'll never find it in Harvard or in Cambridge, by the way. No intelligence over there. Anyways, they sent these discs out there, hoping that someone out there will find it someday. It's just crazy. It'll never happen.
I mean, it's a nice hope gesture.
It's hope. It's
a nice little gesture, but it's probably on a rock in the middle of space somewhere.
No, it's that again. Civilizations only last 200. To the point where they can use electricity, electromagnetism, and so on. It lasts only 200 years. That's not even a drop of water in the ocean of time of the universe. I mean, what is 200 years in gazillions of years, in eternity of the universe? Nothing. And so you have to find not only some civilization that grew up, that evolved in some planet within 100 light years, And that's only one way. Because round trip, for them to answer, that's another 100 light years. For them to send it at the speed of light, that's 200 years, you're over. You're not, you won't receive the message, even if they received your message. And right now, we haven't found any life, at least at the level of managing electromagnetism, 100 light years around us. So
on top of the fact that even if someone did find it, they'd just be like, "Oh, it's just another record."
Yeah, I mean, one thing
they wouldn't even know it's extraterrestrial.
It would have to coincide not only in space but in time. Space, it has to be within at least, I would say, 100 light years. That means at the speed of light, you send a message, and in 100 years they receive it. That's one issue. The other one, it's got to be not only an issue of distance, but it's got to be an issue of time. Is that planet, I mean, when you send it to them, maybe they're still in the planet of the apes over there. By the time, it gets to them, they have to evolve another a million years before they become human.
Let me cut all your things down with some Star Wars. There was a scene in Star Wars where Luke Skywalker, the robot on Luke Skywalker's ship, tells him the odds of him surviving. Beep boop boop. You have 0.2% chance of surviving, and Luke Skywalker says, "Never tell me the odds." That's basically it. Don't tell me the odds. Just send the record out into space.
So, and anyways, even if we leave some proof that we were here. I mean, what more proof than a bunch of skeletons on the last day of Earth? You come here and you see, I mean, if the Martians come here tomorrow, and
they did, yeah. Holy
someone
shit.
lived here. I mean, but what are the chances of someone coming here? None. Absolutely none. It's less than zero. Okay, another fellow says, we need something like a land reform because, let me evolve on that. Because most of the land is monopolized by corporations. Maybe at some point, for survival reasons, it will have to come down to stealing farmland from them. And all I can do is remind you that we had what is known as the enclosure movement. Probably started around the 12th century, but it really took quite a bit of effect in the 15th and 16th centuries, which is when they started enclosing the land and kicking the poor people out, because what were, up to that point, public lands were being enclosed. And when they were enclosed, they drove the people who used to take their cattle or whatever, their horse there to eat, and suddenly that land was not available to them. A lot of these people had to go to the cities, find jobs in there, and the land became more productive by the people who were profiting from them. In other words, they made it more productive. And this comes from the enclosure movement. You can look that up in Wikipedia. The appropriation of common land, enclosing it, and by doing so depriving commoners, like you and me, and the rights of access and privilege. The primary reason for enclosure was to improve the efficiency of agriculture. And it was really not, in the 15th and 16th century, it was not so much agriculture, it was sheep. Sheep was very lucrative for a lot of these landowners, and so they said, I'm going to put sheep in there, and you get your horses, your cows, whatever you've got, out of here. And so they would kick all the poor people out. And Thomas More wrote in Utopia, his 1516 book, your sheep, which are naturally mild and easily kept in order, may be said now to devour men and unpeople.
Unpeople.
So unpeople like you and me,
I like that word.
We're going to be eaten by sheep. Not today, I mean, maybe not by sheep, but whatever the agricultural corporations decide to grow, or,
the unpeople.
whatever they decide to do with the land. I mean, they're the owners of the land, and supposedly they're running it more efficiently than if we have all these little farmers doing their own thing. So yeah, farmers are being bought out. A lot of them are being driven into bankruptcy. They can't pay some of the bank loans, so they have to sell their land. And even though they had generations of, their forefathers lived in that land, now they got to move out. Big corporations are taking over those lands. They have money. They have some tax breaks from the government, et cetera, et cetera. And what they're doing, supposedly they're plowing, the land much better than a small farmer who cannot compete against them on the market. And little by little, we're getting rid of the small farmer. That's why we advanced nations like Germany or the United States, maybe 1% to 2% of their population and of their GDP is agriculture. That's how efficient we are. The rest is all manufacturing and services. We can't rely on the little farmer anymore, so the big corporations are buying the land, making it more efficient. Are we ever going to get it back? I don't think so. We're going to stay in the cities looking for jobs or relying on government help. That's more or less the situation right now. That's why I don't think that is sustainable for the next million years. Absolutely not. That's why I'm saying we are the last generation of humans on Earth. Here's another comment, says, you claim that you caught arthritis. This is related now to, a lot of people have these ideas about medicines and the rich and powerful who are poisoning us with their food, etc., right?
They are.
Okay, diseases are consequences of bad lifestyle and wrong diet. we're obviously raw vegan primates, as no sane animal cooks its food. Okay? Raw vegan diet, natural hygienists have rational explanations for disease formation. They did it in 19th century. Rockefeller took over medicine and transformed it into snake oil salesmanship in 1910. Live longer, stay away from quacks in white coats. Okay, so what can I say to this fella? He obviously has a grudge against some of these rich people who he believes are poisoning us, maybe with additives and so on. So here's my first comment on that, okay? These people, the filthy rich, do they eat foods with additives, or do they avoid them and just give them to us unpeople?
The unpeople. I love that word.
We're the unpeople.
Unpeople.
So are these people poisoning us only, or do they eat hamburgers as well?
No, they have real people food.
Yeah?
Yeah.
You think they eat differently than we do, or?
They definitely eat differently, but I mean, how differently?
I mean, do they ever eat a hamburger? Do they ever put sugar in their coffee?
That's the thing. I mean, no matter what, that food rolls around all over the place, and how are they supposed to track who gets the poison food and who doesn't?
There you go. So I don't think that's the case. But I'm more concerned about this fellow with talking about vegans. Vegan, you know, I eat veggies. In fact, I was thinking the other day that I like almost all vegetables. I don't think there's a vegetable I don't like anymore. I used to not like beets when I was a kid. My mother used to do borscht. She did it very well, but I didn't like borscht. I liked the borscht, but I didn't like the beets. And I didn't like sauerkraut, which is, again, you know, she prepared it very well, but I didn't like it. And today I even eat those. So I don't think there's a single veggie I don't like anymore. But I eat meat. I mean, I love to eat salami with wine. I don't think those two are good for your health, but I just love it. And I'd rather live 1 year less and continue eating that stuff and not avoid them. But the issue is, you know, some people have problems with the ethical part. The fact that we're killing animals. In fact, we're doing even worse. We're putting them in corrals. We're putting them in pig pens. We're putting chickens in little cages. And people say, well, that's immoral. It's unethical. What can I say? You know, we are the top predator of the world. And we can do anything we want. We're like gods. And people don't like that. It says we have too much power. We shouldn't be abusing the poor little animals. And we shouldn't be killing cows. We shouldn't be killing pigs and so on. They think it's disgusting. It's a disgusting practice. And all I can say, we've done it for thousands of years. I mean, you know, those spears that our ancestors had, they were not to hunt lettuce or tomatoes or catch apples from the tree. No, they were to kill animals. And we were primarily hunters. We killed animals, and thanks to our forefathers, we are here. Okay. Now the new generations, they have their tummies filled, and now they have opinions. They say, well, maybe we shouldn't be killing animals anymore. You know.
They have their opinions. That's such a condescending way to put it. Oh, you have your little opinion. Yeah, go fuck yourself. And shitty baby opinion.
And here we have the famous PETA people, and what do they say? Well, this is their take on ethics, okay? And they are known as the People for Ethical Treatment of Animals, otherwise known as PETA. And they oppose what? Speciesism. Okay? What is that? Non-human animals are not objects that belong to us. They're individuals with their own interests, just like us. Addressing speciesism and acknowledging other animals' rights can be as simple as respecting their needs or leaving them in peace. You know, I can't imagine a lion thinking like this. You know, lions don't have ethics. In fact, I was watching one day how a leopard had caught a baby gazelle, and he didn't kill it because he realized that baby gazelle couldn't run away from him. And so he was playing with like cat and mouse, you know, playing with the gazelle. The gazelle tried to run a little bit, and the jaguar would catch him back again. And far away was the gazelle's mother looking at the whole scene. and trembling and seeing, just suffering for her baby there. Well, the jaguar eventually took the baby up a tree and ate him. Now, no ethics there, no pity. And I think what we have to understand is Mother Nature does not care one iota about love. There is no love out there. In fact, she wants the opposite. She wants competition, killing. You're supposed to hunt. The day that we become complacent and introduce love or ethics into the picture, we are violating Mother Nature's law. Okay? So we don't want love because Mother Nature doesn't understand love. And
it's
here
kind
it
of
is.
Fucked up when you put it like that, but it makes sense.
Here's Mother Nature, and this is what she says. She said, I invented love solely for reproduction. That's what love is, according to Mother Nature. That's physics.
Physics.
This thing.
I don't know about physics. Okay,
this thing that we have in our minds, humans have distorted my intentions and use love for pleasure and recreation. The fact that we get a kick out of it,
being nice to the animals.
Love, we take it a little further and we say, oh, ethics and so on. Mother Nature doesn't care. She wants war. She wants killing. She wants murdering. She wants the lion to kill the wildebeest because that's what she made the lion for. And to say, well, the lion now has to give up his practice and be kind to the wildebeest and so on, And here's another vision of what love is to Mother Nature and what it is to others, okay, that do not follow her rules, okay? So here we have, a situation where, we think that love has to do with attraction of some kind. No, she doesn't care about that. She wants reproduction. That's the only purpose of love as far as Mother Nature is concerned. That's pure physics. Anything outside of that, any consideration for some other animal, she doesn't care about that. Okay, and let me put it in a different way, because people are for sure going to string me. Even my staunchest supporter will want to kill me here. And I say that there are animals that we should kill deliberately. We should kill. No. Well, aside from those, but we should kill the lion. All lions on earth. We have the power to do. We should do that. We should kill all lions, all alligators, all wolves. All animals which are dangerous. We have no need for these animals other than beauty, whatever you want to call it. Okay.
What's wrong with that? What's wrong with beauty?
Mother Nature doesn't like beauty. She didn't invent these animals. She said you have to. If you're the top predator, you're supposed to kill.
Kill
T-Rex.
everyone.
Yeah, T-Rex did not have any compassion for anyone below it.
Well, yeah,
anyone who appeared in this.
What I would say to that is we've essentially killed them off, and now we're just keeping them around as toys.
Now we have them for zoos, for entertainment. That's not what Mother Nature made the lion for. She made the lion so that we would kill them all. That's why she made the lion. Okay,
he's a
competitor. The lion is a competitor of ours. We're supposed to kill him because he's
a
dangerous animal for us. So is the alligator. So is the shark.
I mean, if you take it to the extreme,
we have no need for them.
If you take it to the extreme, according to Mother Nature, we should be doing whatever we are doing, right? If we're doing it, then that's what she programmed us to do. It.
We kill other humans. Forget about the animals. We kill other humans. That's what Mother Nature wants. She wants competition. She wants killing, murder.
Okay. Relax. Got a lot of bloodthirst in you. Kill them all.
Okay, folks, let's go on to the muon. What is the muon?
Yeah, now let's go on to the muon after killing everyone.
Okay, here's the muon. You always want to see what a muon looks like. Here it is, folks. Okay, take a look. Good look. Take a snapshot if you want. There it is.
How long do you spend on that picture, boss?
Well, not supposed to be. I guess that's not the muon that I had in mind. No, I think this is the muon, okay? It looks something like that. What a muon.
Ooh,
it's that little M there at the bottom, okay? The letter mu. That's what's called a muon. And as you can see, it doesn't look like a particle. It looks like a trace. So the muon is a trace? I mean, what is this thing called a muon?
Yeah, what is a muon?
I thought muon was supposed to be a particle.
that
So, well, let's find out. I looked it up, find out what is a muon. I mean,
is it like
I heard that it's something.
and all these things?
Well, it's not the cow that says muon. It's not the little tray. So, what is a muon? And you look it up, and okay, and here it is, the definition of what a muon is. Okay, it says muon, an elementary particle. Okay, similar to the electron with an electric charge of blah 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 and a spin of half, but with a much greater mass. So all it is a heavy electron. Okay, it is classified as a lepton. Okay, as with other leptons, the muon is not thought to be composed of any simpler particles. That is, it is a fundamental particle.
There's that fundamental particle until they break it apart, and then you find.
Yeah, this is crazy because they say it's an elementary particle, a fundamental particle. In both cases, it means that it's not made of anything simpler. It doesn't have components. And then they talk about breaking it up and creating neutrinos with it, and electrons. And it says muon is an unstable subatomic particle with a mean lifetime of 2.2 microseconds. Okay, so it lasts very little, 2.2 microseconds.
Just long enough for them to get their calculation out.
More or less.
We don't need it anymore.
But this is the issue. The issue is they say it's a particle. Okay, so now we know what it is. Some kind of particle. It's going to be on the standard model. But then you look up and you find this in there, this fellow, and his name is David Tong. He's a physicist or mathematical physicist, right? And he says something different. He says, and we talked about this in the past, recent past, so it's kind of brushing up on what we talked about a little while ago. It says, the best theories we have is that the fundamental building blocks of nature are not particles. Are not particles. I thought the muon was a particle. Now you're just saying that this is a fundamental particle, right? So you're saying they're not particles. So okay, so what are they? But something much more nebulous and abstract. The fundamental building blocks of nature are fluid-like substances. Fluid-like substances. I guess molasses, which are spread throughout the entire universe. So we have this particle that is not really a particle. It's some kind of nebulous abstract substance which is spread throughout the entire universe and ripple in strange and interesting ways. These fluid-like substances we have a name for. We call them fields. So he's saying this muon is not really a particle, because we're talking about elementary particles. He's saying, well, elementary particles, fundamental particles, are not really particles, like a corpuscle, it's like a little dot there. No, it's some kind of thing, that substance that is spread out throughout the whole universe. So it's kind of weird, because it's very hard to imagine a little particle that is also at the same time spread out throughout the universe. What are he talking about?
It's a really big particle.
Yeah, the biggest particle you ever saw.
We're in a big particle.
And here you see, he continues.
This thing again.
He says, if you're a physicist, you have a very different picture in your mind when you think about fields. And I'll tell you the general definition of a field. Okay, what is it? It's something, right, that is spread everywhere throughout the universe. Okay, so they like the field. Why? Because it's spread out, and they're going to explain, or try to explain, with this word field, action at a distance. That's what they cannot explain. They cannot explain pull specifically, the force of pull. And so the field comes in handy when the particle fails. They cannot, with a discrete particle, explain pull or action at a distance. That's the issue. And he says it's something that takes a particular value at every point in space. So we have values at each point in space, which doesn't concern us. That's a mathematical description. It has nothing to do with what a field is, if it's a what at all. Okay, we're talking about what's. What is a what? A what is an object, a thing. And we're not talking about things so far. They're talking about values. What's more, that value can change in time. Again, they're talking about math here, not physics. So a good picture to have in your mind is a fluid which ripples and sways throughout the universe. And there you have a picture of what they think is vacuum. They say the vacuum, when they remove everything from the vacuum, you still have whatever that nonsense is there. They say those are fields, whatever a field is, because again, I see only discrete things in there, and they're saying that the field is like something which is continuous all the way to the edge of space-time. That's not what they're illustrating there, but they illustrate these, looks like particles appearing from the void, and they're saying these are fields. Okay, so we have a problem because what they illustrate does not match what they're saying. In fact, I doubt very much anyone can illustrate a field because there are different notions of what a field is, and it's all ad hoc. When they need the field for this, they'll put all these little particles, and they say they pop in from the void, and they vibrate, and when you say, well, how does it affect that thing over there? Well, it's continuous. It reaches all the way, stretches all the way to there, like an ocean.
Well, where else do you need it? You need it over there, it stretches there too.
And again, the notion that they're giving you is that you have this ocean, and you have the waves. Okay, and the waves are the local vibrations of the ocean. So the local vibrations, the particle, and the ocean is the field. One problem with that is that that's a two-dimensional picture, notion or visualization, because you're talking about what's happening on the surface. That's a wave. And our universe is at least 3D as far as the eye can see. And so you would think that, how do you wave something within the ocean? What is it, a current? What is this? So
that's true.
It's a surrealistic vision that these people have. Okay. Anyways, here's the formal definition of field. Okay, I've shown this in the past, and I'm not going to go through all this again, but it's a quantity. Okay, it's a number that has a value for each point in space and time. Okay, so he's right. It's a mathematical concept, this thing called field. So we start off on the wrong foot because we're supposed to find out what a field is, like a thing, and it's not a thing. It's a mathematical concept, an abstract mathematical concept. And that's what underlies the muon, which is supposed to be an elementary particle, which is a field. So you can see where this is going. We start out on the wrong foot, okay, because the muon turns out to be some kind of vibrating field, which is a bunch of vibrating values. Okay, so far so good? Catching up? Okay.
Circular definitions.
Yeah, well, no definition at all.
Field, yeah.
What they did is avoid the definition. In fact, you're not supposed to define if a muon is a thing, you're supposed to point to it. Like you point to a table and say, that's a thing. What do you call it? I call this thing a table, and that one a stone, and that one a tree. Then we can all understand. So you have to point and say muon. That's not what they do. They say, look, it's a field. And what is a field? Well, it's a bunch of numbers, and they vibrate, and they stretch all the way to the edge of space-time. That's an explanation. We don't need a definition. We need for them to point to the muon. Okay, so here this fellow again continues, and he says, you take these two magnets, and you move them together. As they get closer and closer, there's this force that you can feel building up. That the pressure that pushes against these two magnets, it's just a little bit magical. This was Faraday's genius. It was to appreciate that even though you can't see anything in between, the space between these magnets will seem to be empty. He said, nonetheless, there's something real and physical there. Okay, so a field is something in there, not the field itself, but something in there. Inside the field is physical and real, which is invisible, responsible for the force. He called them lines of force. In other words, a field is made of lines of force. It's not the field which is the object, it's the line of force which he's saying is the object. We now call it the magnetic field, meaning all the lines of force form a magnetic field. What we need to identify is the line of force. What is this line of force? Not the field. Field is a bunch of lines of force. What he envisaged was that, threaded everywhere throughout space were these invisible objects.
I've heard that one before.
Sounds like the rope model there, threaded everywhere throughout space were these invisible objects. That comes out of a so-called mathematical physicist. Yeah, you have to have objects in there. You have to have things that are threaded throughout the universe and connect things. That's what the notion that they want to give you with field. Okay, but then when you ask them, well, what really is a field? Well, it's a bunch of numbers. Well, that's not what you just said. You said that everything is threaded throughout, and it's the threaded throughout being objects, right?
Lines of force.
That's what a field is. All the things that comprise the field, which are the threaded throughout. Okay, and so yeah, you need physical objects to do physics, and for that you absolutely need, to illustrate the object that you're referring to. Okay, and yeah, Faraday and Maxwell both said it. Here it is. Faraday said, I cannot conceive curved lines of force without conditions of a physical existence in that intermediate space. And Maxwell said more or less the same thing. He defined it in his book. Field, the space in the neighborhood of the electric and magnetic bodies. In that space, there is what? Matter in motion. Matter in motion. That's what a field is. A field is not a thing. It's a concept. It's a dynamic concept made of matter which is in motion. What you have to identify is, what is that matter? What does it look like? What do we have there? What is that invisible region there that has this, object that's moving around inside the field? That's what you got to identify. Until you do that, you're not doing physics. You're doing math, maybe. Okay, so here's the muon, and fellow synthesizes. He says, cosmic rays made up mostly of protons collide with molecules of Earth's atmosphere, creating muons. That's the origin. That's the birth of the muon. Okay, there's a collision between cosmic rays, which are primarily protons. They collide against something. Okay, could be the atmosphere of Earth. And now they're going to create this thing called muon, which allegedly is an elementary or fundamental particle, which is a field, which is who knows what. Okay? Stationary muons have a mean lifetime of 2.2 microseconds. Stationary muon could take about 34 microseconds to fall distance 10 kilometers from Earth's surface if they're traveling close to the speed of light. Okay, so you would have 34 microseconds, again, maybe 17 times as much as the stationary muon. Okay, so this one's traveling. It reaches the Earth if it can live 34 microseconds. But they say, well, the average lifetime of a muon is 2.2, so there's no way it would arrive at the Earth's surface. Yet many muons reach the ground. They do reach the ground. That means that they apparently are living more than 2.2 microseconds. They have to live at least 34 microseconds if they want to reach the ground. So how is this possible? There seems to be a contradiction there. Time dilation, muon lifetime larger for an observer on Earth. That's what's happening. What's happening is they bring time dilation, special relativity, to explain why the muon survives all the way to the Earth, despite the fact that it only lives 2.2 microseconds instead of the 34 that it would need to reach Earth.
What does the observer on Earth have to do with the... Either the muon lived 2.2 microseconds, or it hit the ground.
Well, here it is.
They're mutually exclusive no matter what you do.
You would think, and that's what I'm going to show right now. But let's get to this point. Rather than question the idiocy of quantum mechanics, the mathematician used the muon as proof of special relativity. Okay, so instead of saying, look, there's something wrong, we need to erase the board and start all over, they said, no, we have a solution.
Ta-da!
The solution is that if we bring special relativity in, we can explain why the muon reaches all the way to the Earth, despite the fact that it would be required that it lives 17 times more than it usually lives. This is the problem. We have a problem there, and they solved it with special relativity.
Lengthened time for itself just to hit the ground.
Yeah. Okay, so here's the description out of the Wikipedia. Although their lifetime without relativistic effects would allow a half survival distance of only 456 meters, the time dilation effect of special relativity from the viewpoint of the Earth, meaning the observer, right, allows cosmic ray secondary muons to survive the flight all the way to the Earth's surface. Since in the Earth's frame, the muons have a longer half-life due to their velocity. From the viewpoint of the muon, now we have the muon. He's going to be thinking. He's going to be analyzing himself, okay? The muon, on the other hand, it is the length contraction effect of special relativity which allows this penetration. Since the muon frame, its lifetime is unaffected, but like it says there, length contraction causes distances through the atmosphere and Earth to be far shorter than these distances in the Earth's rest frame.
So we see it as thousands of kilometers, and it sees it as only 400 meters.
Exactly. The muon has a short.
So we see it is traveling a bunch of
kilometers,
short-sighted, and the muon says, "No, it's only 300 meters." What you talking about?
Yeah.
The distance for it is shortened, but not for us.
And that comes out of Einstein's relativity, which says that when you're traveling at the speed of light, what you see in your frame of reference is different than what the observer from far away sees. For you, everything is normal. You look around yourself, everything is normal, everything's stationary, more or less. The tear is there and everything. But if the Earth is flying at the speed of light, right, the person far away will see you a little different, or will time you a little different than what you're timing things happening around you. That's more or less the idea behind the muon. And so here we have one MIT mathematical physicist, and he gives us an example. He says, muon lifetime, again, 2 microseconds, right? If the particle were moving at nearly the speed of light, it could only move about 600 meters. How can a particle that is produced 20 kilometers above the Earth reach the ground if it decays in 2 microseconds? Special relativity saves the day. Suppose the muon is moving at 99.99% of the speed of light. As seen on the surface of the Earth, time dilation stretches out its lifetime to, makes the calculation, comes out to 140 microseconds. With this lifetime, the muon can travel a distance of 42 kilometers before decaying. The muon can easily make it from high up in the atmosphere to the ground. Okay, and this was published by the MIT people. Okay. So there you have the example. Muon is essentially a particle of distance travel, as I say. And for this, we need to distinguish between distance and distance traveled. Those two have nothing, one has nothing to do with the other. Okay, they're comparing apples and oranges, the mathematicians as always. Okay, so here you have a muon. Okay, it's going to go in a straight line all the way to the Earth. Okay?
Yeah.
So they say the muon shouldn't be doing that because it only lasts 2.2 microseconds, and it would take at least 17 times as much if it travels close to the speed of light to reach the Earth. Okay, so what happens? What we're looking at is the locations. Okay, what you just stared at was a movie, a film of the muon falling, and if we chop that up into all the frames, right? Each location that it has with respect to the Earth, right? Then you would have something like this. You would have different locations of the muons. Okay, you would just partition it into frames or locations. In this case, frames and location, frames of the movie and locations, you could say, are the same thing. Okay, so what is the issue here? Okay, why don't we have the muon so that we can distinguish between distance and distance travel? Let's have the muon travel only halfway. Okay, so here goes. Muon only travels halfway. Now we're going to look at that situation there. Okay, and here we have it. There it is. You have the, on the one hand, you have all the frames in the film of the distance that it traveled, and on the other, you're going to have the distance that it still has not traveled. Okay, so one is a movie, and the other one is like a photograph. It's a static image of a separation. Okay, from the muon where it ended up last to the Earth's surface. And here you have, we label this so that you know what we're talking about here. One is distance traveled, and the other one is distance. Distance is just separation, whereas distance traveled is, again, all the locations that the muon had on its trip to halfway from its starting point to the surface of the Earth. Okay. And we label that one more time just to make sure. One is a movie and the other one is a picture, okay? Yeah. So that we understand exactly what, hopefully everybody understands what we're talking about here. We're saying that one is distance traveled, the other one is distance separation, okay? One is a movie and the other one is a picture,
even photograph. Wrong. Photograph also is wrong because it's more like a mental.
Well, it's a static.
Right?
It's a static. What I'm saying is distance is a static concept, whereas distance traveled is not.
Yeah.
Distance traveled is motion. Distance is, it's just a separation.
Yeah.
Okay, that's what I'm trying to say here. Okay, so we got that, at least the notions. What's the problem? Well, first thing we have to do is define words so that we know what we're talking about. And let's define them, okay? We say that an object is that which has shape. Distance is the separation between objects, okay? We have two objects there, two blue boxes, and this is just a region between them that has no matter. Location is the set of distances, one object with respect to all the other objects in the universe. And distance traveled, something totally different. We call it motion, displacement, you can call it if you want. Two or more locations of an object. That's a dynamic concept. Okay, so these are all different notions, different concepts. And so we need to understand the differences between them. Okay, so what's the issue? When the forefathers, people like Lorentz and Poincaré and so on, they came up with this length contraction, as they call it. They were actually comparing apples and oranges because length is not distance. Okay, length has to do with what an object measures and not with the separation between two objects, which is what distance is.
So we have length, distance, and then distance travel.
And distance travel is something totally different because it's what one object traveled. It has nothing to do with separation.
Did you say distance is the length of space? It's a weird way to put it, but
yeah, but length should be reserved for objects, for things. That's where the problem is. Okay, so they use this, but look at this. The issue is that velocity there is distance traveled and not distance. And today everybody uses the word distance when it's not distance. It's very confusing because people think that they're talking about separation and they're not. They're talking about a movie. They're talking about a little ball that is at different locations. That's what velocity has to do with, and not with separation between two objects. Okay, so that's the first thing I want to point out. Okay, and here we have my versions to show you the difference. Distance is what lies between lengths.
Yeah.
That's a way we like to synthesize that. Length is what an object has. The table has length. Between two tables, what we have is distance. Okay?
That's essentially it's like what I said. Distance is the length an object would have if it were in between those two.
Yeah, but see, the issue here is that the mathematicians, whether they're going to measure a table or whether they're going to measure between two tables, they have to unroll the measuring tape. And what they're doing in all these cases is measuring or counting how many units of that measuring tape either the table has or between two tables. In other words, for them, it's all the same. They're going to talk about meters, and what they're doing is counting the number of meters between two tables or one edge of the table to the other edge of the table, or the amount of time you ran. Right. All that for them is the same. It doesn't matter. So it's like the issue with dimensions and coordinates and vectors. For them, it's all the same because they're not talking about dimensions, coordinates, or vectors. What they're talking about is number lines. And here they commit the same crime.
But how is that relevant?
Okay, let's show why it's relevant. Here it is. Okay. Here we have location, location, location. This is what I want you to pay attention to. Here we have the universal movie. Okay. Universal movie, every frame is a location. Now you can chop that up as much as you want. You can say that every frame just represents 1 gazillionth of a second. It doesn't matter, really. You can also say that it's just 1 second. The important thing here is that you see the green dot there that's moving around. It has location with respect to every atom in the universe. Okay, that's what the red arrows are showing. So, but there has to be a correlation between the universal movie, every matter in the universe, and the local movement of the muon. Okay, the local movement of the muon is a movie also. And there has to be correlation because the local movie of the muon is a component of the universal movie. So there better be a one-to-one relation. Yeah. This is not the case in mathematical physics.
What you're saying is time moves everything at the same time.
Yeah, if
not a little faster for this guy and a little slower for that guy. This guy, everyone's speed has to be this. Everyone's time has to be the same.
This is the way I put it. What we look at here is the following. Let me put this down here so we can. What we have is the following. You have God. You know, God is all powerful. If you don't like God, you pray to the devil. Okay, let's put the devil in there. Okay, the devil stops the universe. There's nothing moving.
Yeah.
No electron is moving. No atom is moving. Nothing is moving. He froze the entire universe, all the matter in the universe. That's a cross section of time.
Okay.
So that cross section of time is or cross section of motion, location. That's all we have. In that frame of the movie, all we have is location. The next one, the next frame is also location, just location. So we have motion built from all these locations because motion is two or more locations of an object.
Okay.
Okay? There has to be a correlation locally to the rest of the universe.
Yeah.
Okay? So if a muon is moving here in this region originally, right, we don't care because the location of that muon at any point in time has to correlate to the rest of the universe. It's got to have a distance to every object in the universe.
Yeah.
That's my point, okay? And so here we see, let's put it back. Here we see that according to mathematics, that those 10 frames that you see there, they only form a small portion, less than 1 second of the universal movie. The universal movie is every object and the distance from every atom in the universe to every other atom in the universe. That includes every muon in the universe.
Yeah.
Okay? And what these people are saying is the muon lived or thinks it traveled only less than 1 second, meaning it got rid of a lot of frames, or it's missing some of the frames of the universal movie. Somehow these people made the movie, some of the frames in the movie, some of the locations disappear.
Yeah.
Because there's no other way that you can say that for the muon, it was less than a second, but for the universal movie, the whole thing lasted more than 1 second.
So you're saying Father Time has to audit the muon?
Well,
hey, buddy, you're missing some frames here.
What I'm saying essentially is, you can't have it both ways.
Yeah.
Math is one thing. They can do all the calculations they want. They can take Lorentz contraction and do whatever they want, play around with the numbers. That's fine. They can do whatever they want there. But when they come to physics, the muon has to have location. Okay? That's a qualitative notion. Yeah. It has to have distance with respect to every atom in the universe. Yeah. And if you say, look, locally, what happened to the muon, it did this very fast, below 1 second. At the same time that for the rest of the universe, it was more than 1 second. Okay? Let's just put it in those terms.
Yeah.
You can't have that because location has to be for every frame of the movie.
Yeah.
And these people are saying, look, we got rid of some of the frames, some of the locations.
But only in one of the movies.
Locally.
Yeah, like what?
So one of the two, someone's missing or someone's putting too many frames of the movie, depending on what side you're looking at from with the context. There has to be location per frame, one location per frame for every, you have to count for every location of the muon in every frame of the movie.
Essentially what you're saying is doing. 1 second passes the same for everything. The best way to put it, like, is kind of how you define a year, the Earth going around the sun once. Assuming we made this really slow, right? How many times did let's say a muon lasts 1 year for itself and 2 years for everyone else, right? Did the Earth go once or twice around the sun?
Yeah.
By the time it hit the Earth.
And all we have to do is go to the file cabinet, the Devil's file cabinet, open it up and find out what was the location on that file. And we pulled it up, and that's a single frame of the movie. Yeah. It has only location. The muon had better be in there. Okay, in every frame I should see the muon. And these people are saying, no, we got rid of some of them only locally for the muon, but the rest of the movie, universal movie is okay.
But isn't that a general problem with special relativity?
Yeah,
it's just a general problem because that is essentially what they're saying. They're saying for some things time goes faster, for some things it goes slower.
Yeah, that's okay in math. You can do all the calculations you want, but we're talking about qualitative location.
How many frames were there?
Every object in the universe had better have location.
How many
Even
seconds
God,
passed? If 2 microseconds, or what was it?
Yeah, 2 microseconds.
If 2 microseconds passed, right? Is the muon dead or did it hit the ground? We don't care about the rest of it. Where is the muon right now after 2 microseconds?
Look at the file.
No, but essentially that's what you're saying. From the beginning of when the muon started, just start the timer 2 microseconds. Is it dead or did it hit the ground? they're mutually exclusive. It's either dead, so only 2 microseconds pass, or it hit the ground, so the muon lives more than 2 microseconds.
Well, what they try to get around that, saying that what the muon experience is different than what you experience as the observer. And I'm saying we don't care what people observe, what they calculate. We don't care about any of that. There has to be one location per frame in the universal movie. And the muon had better be in each one of those frames. And you cannot say, well, for the muon, there were 10 frames, but for the universe, there were 1,000,000 frames. You can't do that. I mean, this is what they're saying. They're eliminating locations of the muon.
That's what I'm saying. We got to audit the muon. Hey, buddy, you're missing some frames.
We got to go to the devil's cabinet and find out what's in there.
Okay. So someone's cooking the books over here for the muon.
Anyways, here's the conclusions. Okay. Oh, sorry. Wrong one. Let me get rid of this one.
How many frames per second does the universe play in?
Well, you can make it gazillions of a second. I don't care. It doesn't matter to me. Really, you chop it up as much as you want, but there had better be location for every object in the universe. Otherwise, the muon disappeared, or some of the frames disappeared. Okay, so here's the conclusion. Muon is supposedly a particle, but a particle is a field, and a field is many values.
What's with the sad smiley? What the fuck?
Well, you'll see it. Why? So this implies that the muon is a concept. It's not an object. It's not a thing. Okay? Muon is a concept because it's just the many values, which is a mathematical concept. Muon, even worse, it's a dynamic concept. Why? Because it's the particle, quotations on that, of distance traveled. Muon only has importance in the discussion of distance traveled, okay? Because they want to show you that, the muon went faster than what you're supposed to think about the muon, and the way they explain it is through special relativity, saying, well, for the muon, it was a shorter distance. Okay.
Can we really quick talk about why they even invented the muon?
Well, let me finish this and we'll do that. They depict it as a trace, okay? And the muon is, again, distance traveled. It should have one-to-one correspondence or relation between frames of the movie, of the universal movie, which each frame represents a location only, which is the set of distances to every atom in the universe, every living thing, or every piece of matter in the universe, okay? Anything that exists. That's for the universal movie. And what they're doing is they're either missing or they have surplus frames, depending on the context, from which angle you're looking at it.
Either muon's missing or we're adding too many.
Right. And so the muon has nothing to do with science, and that's why he's got a smiley face. I'm sorry, a sad face. The smiley is no longer smiling. Why? Because the muon is not part of science.
Rest in peace, muon.
Okay, so the issue is the following. The way they detect this is what you got to look at. Again, you have cosmic rays, which are protons. They collide, essentially. They collide against the atmosphere or whatever, doesn't matter. And when they collide, they break up, okay? And the muon travels to Earth, okay? It travels to Earth. But if it's a stationary muon, one that's just floating out there, the average lifespan is 2.2 microseconds. When they're traveling to Earth, they should be, it should take them a little more than 2.2 microseconds, okay, whatever the calculation is, not important. Yeah. But the point is, it's got to have a longer lifetime. Yeah. And what they realize is that somehow they detect them at ground level. Yeah. They were able to detect muons at ground level. They say, how can this possibly be? The muon should have died by now. Yeah. Turns out he didn't die. He went all the way down there, and instead of rejecting the whole nonsense of muons, what they said is, let's explain it with special relativity. And special relativity says, length contraction, distance contraction. The two mountains move closer to each other because the muon travels between them. This
nonsense stacked on nonsense.
Yeah. That's what they're saying. And I'm saying, hey, no problem with all that. That's math. Now, when you come to physics, show me locations of the muon in every. Right. I want to see the muon at every location, in every frame of the universal movie. Okay, let's get on to our science critic. And we always
we
love
have
to hear
critics.
him.
What?
Yeah. No, he's criticizing the scientific method. Can you believe that? 400 years
Who would
later.
do something like that?
Yeah. Anyways, here he is. He is going to talk about experiments. He's saying experiments are part of, science. And we're saying, no, they're not. And so listen to him. Here he goes. Listen carefully. The questions and issues to be addressed in this rebuttal include, are experiments a part of science? And does performing an experiment make you a scientist?
Bill, what do you think scientists do with their time after they graduate? Do you think that they just sit around reading books or something? I mean, sure, reading will definitely be a part of it. There is peer review that has to be done after all. But, you actually have to write papers when you're a scientist. And most likely, you'll also have to do experiments in order to verify the things that you're talking about. Studying can be done by performing experiments, which is something that scientists do when studying. I remember that a large part of my studies were hands-on, especially when it came to things like audio production where you had to set up mics because how else are you going to learn? I have studied computers and audio. That does not make me a scientist.
Okay, so he says that experiments are part of science, but at the same time he says doing experiments and studying does not make you a scientist. He seems to have a contradiction. I don't think he understands what he even said. Yeah. Because on the one hand, he says studying and experiments are part of science or define science, and then on the other says, well, the fact that you study and that you do experiments do not make you a scientist. Okay, so here we go. This is a summary essentially of my criticism of his criticism. Okay, here it goes. Science is not studying, okay, because you can study all day, all night, all year. You can study at the university level and not understand a thing or be able to explain anything. And what is science? Science is rational explanations. Otherwise, you're not a scientist if you haven't explained anything.
Well, it depends on how you define study.
Well,
if you study and you can't explain, some would argue you didn't study at all.
Well, you can study doesn't mean you're going to understand. You can read a book on math and not understand anything. Maybe you don't have the foundations to understand what you're reading or whatever. It doesn't matter. The point is that if you cannot explain, you're not a scientist because science is explanation.
Are you saying, wait, let me break that down a little more then. Are you saying that taking in information isn't the scientific part? That's like,
right. That's more or less
spitting out information is a scientific part. Like as much as you could read every book in the world, you're not a scientist yet. Even if you know everything, until you spit it out of your mouth, you're not a scientist.
And it's not only spitting
out. It's like a professor. You have to profess.
Hold it. But it's not just spitting out in the sense that, I just say whatever I wrote. I recite poetry. No, that's not science. Science is explain to me something.
But right? You could be reciting an explanation that someone else gave.
As long as it's an explanation, no problem.
That's what I'm saying. You would definitely cut off between if the guy read every single Wikipedia and he could explain everything. He's not a scientist yet until he explains.
I'm saying he's got to explain because if he just even if he recites, I mean, I don't care. Because maybe it's his theory. He needs to read it. I don't care. But it's got to be an explanation. If it's just a description,
that makes sense.
What did he do with his brain? I mean, I can describe a chair. That doesn't make me a scientist.
It's kind of weird when you put it like that. Then you could make that identity thing. You could extrapolate that to anything. A businessman, you're not a businessman if you read every business book in the world until you actually do business. Then you're a businessman.
Or explain something in business.
But that's the thing. Unless you do something with it, you're not a doer. You're just a consumer.
Yeah, and in science, the doer, it means you have to explain it at the conference. When you come to the conference, we don't want you to describe something or say, this is what I did in my basement. Yeah. So what? So what that you did this in your, which is what Faraday used to do. He would do all these experiments at the Royal Society, where he did things with magnetism and electricity. He didn't understand anything, but he says, look how neat this is. So he just wowed them with his flashy experiments, but he couldn't explain any of them.
But I mean,
so does that make Faraday a scientist?
I mean, who cares if they're a scientist or not? Really, all we care about is the explanation. We don't care about the person.
Anyways, here it is. Study does not imply you can explain, right? The purpose of experiments is to collect evidence. What is the purpose of evidence? To persuade. Persuade, convince, convert, recruit, all that has to do with religion. Okay, that's opinion. That goes on belief. You know, it attacks belief. It doesn't explain anything. It's just trying to convince you. You know, buy my theory, please. That's what it's all about. That's what experiments are about.
Well, some would argue that you need to do experiments to even get the questions.
Yeah, but that's research. Research is not science.
Yeah, but that's kind of part of it, because you're not trying to explain things of other dimensions that we can't even.
I can do all the research I want. That doesn't mean I can explain anything.
Yeah. But it is kind of part. You can't rip out the.
I do.
Until you drop the pencil, there's no gravity to explain.
For this, you need to define what science is. And if science is explanation, it rules out any investigation. It rules out any research, any anything that you did in your dark basement. We don't care. When you come to the conference, please explain. Yeah. Otherwise, you know, what are you going to do? Just say, this is the experiment I did at home. Okay, it's like Faraday used to do.
Well, yeah,
and you say, okay, what did you understand? I didn't understand anything, but this is,
why does
isn't it a neat experiment?
Why does it have to be either or? Why does it have to be either experimenter only or explainer only? Why not both?
Because the mathematicians only do measurement.
Yeah, then they're not scientists.
And then they bring an equation to the conference. They say, this is the equation. Yeah, but that's a description.
Yeah, because they only did half of it. Well, they only did the experiment part. They didn't do the explanation part.
Yeah, they did stuff that had nothing to do with science. They did technology.
But I would still put the experiment under science.
Okay.
Part of it.
Anyway, let me finish here with this. In fact, the critic, right? Science critic, admits that hands-on does not make you a scientist. He said, a large part of my studies were hands-on experiments, right? I have studied computers and audio. That does not make me a scientist. Absolutely right. You know, it doesn't make you a scientist, and these are your own words. So he doesn't understand the context, because at least on the one hand, he says you need to study and you need to do experiments. I'm saying you need to do neither study nor experiments. What you need to do is explain. I don't care if you studied or not, but if you can explain something even without studying, without doing experiments, you're a scientist. You're using your brain. But to say you studied, you memorized the book, you know the poem, and you can recite it by heart, and you can't explain anything, you're just describing, you know, what a tree looks like, you beautiful, you love, etc. You know, that's not science.
Aren't you stamp collecting right now?
Huh?
When you talk about, he's a scientist, he's not a scientist. Isn't that stamp collecting?
Well, yeah. We have to know what a scientist is because...
Why?
Because...
Why my ass with who a scientist is? Because I don't care if you're a scientist or not. Can you explain what the fuck I asked?
What I'm saying, you need to define what science is, because if we're going to say that physics is a science, we need to know what science is first, then we need to know why physics is a science, and they have to, you know, if I say science is rational explanations, physics is rational explanations of causes and mechanisms, then I have a logical framework for, you know, talking about science.
Sounds like a lot of stamp collecting.
But if people give you 2 paragraphs full to define what science is, and then another 10 paragraphs to define what physics is, because they have all these semicolons and commas and periods, you know, I mean, then, you know, we have whatever. We have what we have today. Okay, let's get to some of the questions people or comments people made. Here's one. Fellow says, Bill Gaty, everything is made of ropes. Ropes are made of threads. That's what I said. And he says, but you can't see them. And he laughs. Well, I should enlighten this poor fellow, okay? And here it is. Quantum mechanics. Everything is made of particles. Particles are made of fields. But you can't see them. So he doesn't criticize quantum. He doesn't criticize the fact that they've never seen a single particle. And then they tell you anyways that the particle is made of fields, and fields is a bunch of numbers, and you can't see them. But he doesn't laugh at that. He said, oh, that's science. And he says that, oh, Bill, you're saying that you have these things you call ropes or threads or whatever, and they're physical objects, but you can't see them? Yeah, you can't see anything in quantum either. So please come up to speed. Anyways, you can't touch them, by the way, okay? Particles can be at 2 places at once. You never asked that question. How can one particle be at 2 places at once? At least we don't say that nonsense, okay? And fields are numbers that vibrate. So yeah, laugh out loud there, okay?
So you're saying you have less inconsistencies
Well,
by far. I mean, that
the-
is essentially what we're saying. The one weird thing about the ropes is you can go through them. But beyond that, we don't. I mean,
well,
if you stack up the inconsistencies of mainstream science, you can make a list. That's what you do professionally.
but it's not only that. It's not only that. There's something else. It's that, but there's something else which is probably more fundamental, and that's the following. We have to imitate. We have to simulate Mother Nature's universe. Mother Nature's universe is that if I drop the pencil, and I've done this experiment.
Oh, we don't have to do experiments. We don't do experiments here. No. We don't do experiments in science.
This is my point. Gravity. We have to explain gravity, right? Gravity is an effect that looks more or less like this. Okay, you let go of the pencil. Yeah. You let go of the pencil and it falls to the ground. Now we have to explain there's nothing here. You can't see or touch what's here or up here. So whether you use the particle, whether you use the ropes, it doesn't matter. You have to explain Mother Nature's universe. In this sense, quantum mechanics is correct. You can't see or touch the mediators of gravity. Yeah. Whether you use particles or ropes, it doesn't matter what you or spirit.
You use anything, whatever it is, you can't see or touch it.
It's all these people who are asking to go into the lab to run an experiment to see and touch, maybe because experiment is see and touch, right? They're expecting to see and touch the mediator of gravity in order to understand. You do not need to do this. You just need to visualize what physical objects Mother Nature could be using. She could be using particles, maybe pushing down on the pencil. Maybe she's using ropes to pull from below towards the earth. Whatever you theorize, no problem. But you cannot use the words see and touch to talk about gravity, light,
we ruled those out.
And so,
obviously ruled those out. So
people should not be laughing when they say, "Oh, I can't see or touch the ropes." Yeah, of course, you can't see or touch the particles either.
That's almost the
so.
That's
almost and it better be that way because that's how Mother Nature runs it. She runs it with invisible, intangible objects. Hopefully, not with concepts. Otherwise, she's doing black magic. She's not Mother Nature. She's a witch.
She's that too, I guess.
Yeah. Okay, so here's another fellow, and he says, Bill, criticize plasma physics. Oh my God, some people still are struggling with plasma. And we define plasma, you got to look up the word. I mean, I can't help you there. Plasma is ionized gas, essentially, that's it. They have also the fourth state of matter, let's forget about that one. Plasma is ionized gas. Ionized is a movie. Sorry to break it to you. Ionized is a movie. Gas, the word gas does not embody motion. You do not have to have gas moving or the electrons moving. We can have a picture like there in a single frame of gas. The devil again froze the entire universe. There's nothing moving. You have that picture, that's a single frame that he's got in his file cabinet. We pulled it out. We say that's gas. It could be air. It could be, hydrofluoric. Phosphine.
So you're saying for plasma, we need a before and after.
Yeah. So in the case of plasma, you need two frames. You can't do plasma because of the definition of plasma. You need two frames. Plasma is something in motion.
Do you need something non-ionized and then something ionized?
Correct. Because
you need to compare it to what it used to be.
If that's one issue. Again, a concept is a relation between two things. In this case, two frames, before and after. Okay, you need to compare. Plasma is a comparison. It's not a thing that stands alone. If you cut the universe right at time, you have a cross section of time, you only have location, you cannot say that's plasma. You cannot say because right now all you have is a bunch of particles there that are neither plasma, neither gas. Plasma requires motion. The removal, in the case of the official version, the removal of an electron. Removal is a verb. The word remove is a verb.
Can't you just take the second frame of that plasma?
No, because then what are you staring at? That's not plasma. Plasma has to be something in motion where you're withdrawing the electron from the atom. You need to have ionized The word ionized has to be covered in the word plasma.
But again,
and
the
these people have
second frame
mental
there.
problems. They don't understand it no matter how you present it to them.
But why can't you just take the second frame there? Because
that's not plasma. Plasma is not the second frame. Plasma is the two frames, the relation between the two frames. You need to remove the electron in order removal, ionized. The word ionized.
I know what you mean.
And people don't understand that plasma is a dynamic concept. It's not a physical standalone object like a tree or a stone or a table. Plasma means you're moving. And moving means two frames. You need two locations, and two locations requires two frames of the universal movie. Therefore, plasma cannot be synthesized in a photograph, in a still frame, still image. And I don't know, some people will never. The reason they don't want to understand it is because they live their whole life with plasma. They're stuck to plasma. And you take that God away from them, you rape their virgin,
hold on.
They're lost.
If you know how copper gets like that weird turquoise look when it gets all rusty or tarnished, oxidized.
Yeah,
that's one picture, but we still you can have oxidized copper as a picture, but you wouldn't say that oxidized copper is a movie.
The transition. Because you have to have a process of oxidation.
Yeah, but when people talk about plasma, they're really just talking like.
Yeah, I know. They want to cut corners. That's what they want to do.
What's the difference between oxidized copper?
Because then you got to, if you use oxidized ed, that means it's a verb.
But if you take a picture of it, we know what we're talking. We know that's
different from what are you going to call it? You call it oxidized copper. Oxidized means something happened to it in the past.
Hold on. What are you comparing gas to? A solid.
No. You don't need to compare.
How do you know? That's how you know it's gas.
No. You don't need to compare. If I look at a table is made out of tons of atoms.
No. How do you know it's gas?
Hold it. I look at a table. It's a solid, right?
Yeah.
It's not a gas. It's not a liquid, right? Table or rock or.
How do we know that?
Solid.
We're comparing it to non-solids.
No, hold it. I'm just saying. When you get something which is a solid, any solid, I don't care which, it's got atoms.
Yeah.
The atoms are vibrating, right? We all know that electrons are, but we're not looking at it. We're looking at the universal movie and cutting a cross section of time.
Yeah.
That means all we're going to have is location. Nothing moves in that frame. Just to make sure that people don't start running with their heads and say, "Oh, but the electrons move." No.
Location of all the atoms.
Here we have the location of everything. The way the good old Lord or the good old.
So how can you tell it's a solid?
Okay, and this is the point. The point is, we look at this bunch of atoms. We say that's rock.
How?
No, hold it. We just give it a name. Yeah. It's just a name for the object. We present it and we say we're going to call this object. All these atoms that are in contact with each other, we're going to call this object rock. Okay, because there is no motion required in the word rock.
Okay, so far so good.
Okay, now
how do we know it's a solid?
No, it doesn't matter.
But that's the question.
No, that's not
What's
the
the difference between gas and plasma? No. How do we know it's a it's a gas? We're comparing it to a different thing, which is
because
not a gas.
The word plasma embodies motion. The word rock does not embody motion. How can I get this through, people? No, the word rock does not embody. You don't need
rock doesn't embody motion.
Good, thank you.
But solid does.
No.
Because you're comparing it to not solid.
Solid is not an object. Solid is not a thing. Solid
is
a category. It's a category.
And so is gas.
No, gas is not. There's gas category and there's also gas. Like I point to a bunch of atoms called air inside a balloon. I say gas. I can say air. I can say whatever you got in there. That bunch of atoms in there.
Yeah.
I do a cross-section of time. Nothing is moving in there, and we call that air or gas. We can call it gas or air. It doesn't matter because both are objects.
But you're comparing it to not
gas. Because I'm not comparing the categories, gas against solid against liquid. I'm not comparing categories.
I think you are.
No. Gas, I'm saying gas like point. You don't know which gas it is. It could be phosphine. So you say gas.
But how do you know it's a gas?
You give it the name. The word gas does not embody motion. There's no motion embodied in the word gas. You don't need to have gas moving from one frame to another to call it gas.
That's not what I'm saying.
But that's what I'm saying.
What?
Yeah, people get so tied up. They don't understand something straightforward.
It's not.
Gas is not a category. I'm not using gas as a category.
How
like
are
solid.
You doing that? How are you doing that?
I'm saying I see a blob of something in the middle of space.
Yeah.
Okay, the astronaut, he blows air into a balloon, right? Okay. And so we got air in there in that balloon.
Yeah.
Now he pops the balloon in the middle of space where there's nothing. Let's assume there's absolutely
and then we stop
nothing.
Time.
No, okay. We pop the balloon. Yeah. You have this blob come out of the balloon, right?
Yeah.
Now we stop time.
Okay.
Now we have a cross section of time. So we have this blob out there just frozen in time. Nothing moves, right? We call that blob. We say, well, I don't know. It could be air.
Let's call it a solid.
Yeah, we can call it whatever you want. It's not solid. Solid is not a category.
Let's just give it a name.
Don't use the word solid.
Okay, then let's call it X.
I see something there, and I call this gas.
Let's call it X then.
No, but I can call it gas. It's a generic term for any gas. It could be air.
Gas category.
No,
that's what you just said. It could be a generic term for any.
I can call it gas. I can call it gas. When you say, I smell gas, you don't know which gas it is. It doesn't matter because you just say gas. I point to it and say gas.
But that's a category.
No.
You can't
I can
separate the category.
No, I can I can use the word gas to refer to a thing as well as a category. I can use it as both.
But you're talking about a group of atoms,
When I see liquid, liquid is a category, right? But I can say, milk. Or whatever. I don't know which one that is, but I can tell the ET liquid.
Yeah.
And he looks at this blob and he knows, okay, that's liquid. The word liquid refers to that blob, that river, that ocean, whatever's there.
Yeah.
So you call it liquid. You can't do that with plasma because you're not talking about something that is static. You cannot point to plasma. You cannot point to gas. You can point to liquid, you can point to gas, and you can point not to solid because there is no thing called solid. Solid cannot be used as a thing, whereas gas and liquid can be used as things as well as categories. Do we have that?
No, we still doesn't make sense.
Okay, well, it'll take a long time. Anyways, the point here is that plasma requires motion. Okay, gas does not. Yeah, I don't need to have motion for any gas. I can have a blob of a bunch of atoms and call it gas. That word is acceptable. Plasma, you need to have motion in there. You have to have ionization. And until people get that through their thick skulls, it's going to be forever, the discussion.
You got to penetrate my thick skull.
Yeah. Okay, another fellow says, objects, fields, and energies have shapes and physical presence. Fields and energies aren't objects. Well, this fellow in the past said the opposite. He said that fields and energy are objects. Okay, so it's very difficult to someone who's inconsistent. That's the first issue. But then what is the shape of a magnetic field? I mean, that's a field. That's what you see for fields. What is the shape of that? Where does it begin? Where does it end? Are those arrows? What are those? Engine arrows? What? And then what is the shape of energy? Okay, so again, fields and energy, they're concepts. They're not physical objects, standalone objects. There's no physical object called energy. Okay, in fact, it's got many definitions because of that, because you can't point to energy. You can't point to field. Okay, field is a concept that says many values, in space.
You just got numbers.
Huh?
We just got numbers.
Yeah, values. It's just numbers with units, Someone says, is a thought object an object? The word tree does not necessarily imply the existence in itself of the thing thought. In other cases, however, it indicates a reality that has its own existence, independent of the knowledge or idea that the thinking object may have of it. The single word is not good if used to define a precise concept. So he proposes using two words, right? Adjective in front of a noun, right? The solution is to use at least two words, such as real object, real thing.
I love real object.
Yeah. So we have a solution for this fellow. We have good solution here. And it is, well, first of all, yeah, he has the same notion that Hume and Kant had. And they, just like this fellow, they confused existence with object. That's the issue. The idea of existence, according to Hume, the idea of existence then is the very same with the idea of what we conceive to be existent. Okay, the idea when conjoined with the idea of any object makes no addition to it. Whatever we conceive to be existent. In other words, according to Hume, an object and existence were synonyms because you add nothing by saying that it exists to the word object. That was his notion. And Kant said more or less the same thing. He came a few years later, but he said the same thing. He says, by whatever and by however many predicates I may think a thing even in completely determining it, nothing is really added to it if I add that the thing exists. So they couldn't tell the difference between thing and existence. And this is our answer, okay? Oh, so wrong one.
Get that picture out of here.
Yeah, we'll cover that one later. Okay, this is the answer. Idiot, individual who has big
Still on
ideas.
that one.
Etymology from the ancient Klingon, idea plus ot. You know, he doesn't have little ideas, he has idea ots. And an idiot is someone who confuses object with exist. Okay, so we got that. Anyone who talks about existence in the context of the definition of the word object, well, the Klingons say he's an idiot. Okay, and so make sure you know where you stand on that. Okay, and I think it's the same fellow. He continues, he says something here. He says, the sequence in defining words is fundamental. Absolutely. And this is what he didn't understand. He said it, but he didn't understand what he said. We must define object before we define exist.
Because you can't have...
Exist only because...
Applies to object,
and there you see it. Only objects can be said to exist. Why? Because object is that which has shape. Distance, as we covered today, separation between objects. Location is the set of distances. And just now we can start defining the word exist, which is what? Object that has location.
This kind of reminds me of programming.
You got to go in steps.
In programming, they also have something called dependencies.
Yeah.
Where something, it depends on the previous thing, so you need to finish that previous thing before you continue.
Because if you did not define that thing, what would happen? You can't. The system doesn't know what to do.
Yeah.
You have to define something.
Yeah.
If it's the precondition for another word.
Exactly.
And
I mean, if you find the word object in the word exist, then you have to define object before you define exist.
Right.
I mean,
and otherwise, you have to define the word exist and tell us what you mean by exist.
And I guess the buck stops.
If you can define it without the word object.
The buck stops at shape. At shape. No, sorry, before shape. At object, because shape is that what you point to, right?
Yeah, object is that what you can put. Shape is like an adjective. No, it's like an adjective. It's like a attribute of an object. It's a universal attribute of all objects, right? Every object.
Yeah, but you say that you don't really have to define shape. That's one that's like, come on.
Yeah.
At that point, it's like, well, what are we doing here?
No, let me tell you why you don't have to define shape, and that's got to do with a totally different context. It's got to do with the fact that everybody wants to introduce see and touch. Oh. And so all we're doing is comparing shape against see and touch.
Yeah, it's a better criteria.
And it's not. It's that shape and touch, see and touch are irrational. You need two objects to do see and touch. You don't need another object to have the notion of shape. Yeah. So, and every object has shape. Not every object can be seen and touched, and so on and so forth.
But don't you need eyes to see a shape?
Yeah, which is, what are your eyes? Aren't they objects? Aren't they things? Okay, so here's the answer to this fellow. Also, mental images, right, or imaginary objects are objects that don't exist. So the table that you have in your mind, that one doesn't exist because it doesn't have location. It's an object because the word table is an object. So if I'm thinking of table, I'm already thinking of an object. But the object doesn't exist because that table does not have location.
That would be.
But all tables, the word table always represents an object. The fact that some exist because they have location, others don't because they don't have location, That's what separates objects that exist from those that don't exist.
That would be a big difference between you and Hume and Kant, because they would say that all tables, by definition, exist since they are objects.
They never thought about the Klingons' table that they can't see or touch. Anyways, the table I put here, my beer mug on, is an object. Okay, that we're talking about a real one there, right? And this table has location and therefore exists. The table I'm imagining is an object, right? Because the word table always refers to an object. The table I'm imagining does not have location. Therefore, the table I'm imagining does not exist because it does not have location. And with that, I will see you.
No, we got 2 more questions.
Oh,
that I memorized them.
Oh, okay, go. Yeah, go.
One was, how can you say we're the last generation on Earth with your progeny sitting next to you?
I want to kill him. Sometimes I want to kill him. No, the word generation. I mean, look at the following example. Newton was born in the year that Galileo died.
Oh, shit.
Were they of the same generation? I mean, they both lived in the 17th century. One died in 1642. The other guy was born in 1642. And so the question is, were they of the same generation? What do we call a generation? The 100-year period, is that a generation? It should be called a 20-year period. And all I can tell you is the word generation cannot be perfectly defined.
All I'm saying is, I got one.
Okay.
How old is the oldest person? That's the generation.
He just died.
Yeah, but let's just give it a number. Assuming right now the oldest living person is 104 years old, I'd say that is the generation until that person dies.
Well,
everything before that person's time is by definition history.
No, because let me tell you, there's another way of looking at it. You can say generation is people who dress the same. You can say generations, people who thought the same or had the same ideas. There's different ways of categorizing generation. Like you say the 90s generation, like all these people thought the same way or they liked the same music or whatever. Yeah, you cannot define generation, or there are many contexts.
Call it a group, isn't that easier? The last group of humans.
Yeah, I guess you can use any word. My point here is that extinction is imminent, okay? And yeah, that includes my dear son here. One of my dear sons. I got 3 sons.
The other question was a common one. Is space an object?
Well, we have to define space and objects, and they are different. In other words, let's put it in better terms so that you can see the difference. One is called something, and the other one is called nothing. Something, hopefully, is the opposite of nothing. Something, that which has shape. Nothing, that which doesn't have shape.
Sounds like kindergarten.
It is. It's kindergarten stuff. And now we can use these words consistently in any discussion, because you say something and people say, oh, I know what that is. That's that which has shape. What is nothing? That which doesn't have shape. And it's the opposite. They're antonyms. So it's perfect. Now you can use these words. But to say, that which I can see or touch, well, can you see or touch space?
Space, yeah, it gets weird.
And well, if you leave it up to the mathematicians, they say there are fields in there, we can see or touch them.
Can you say that you're seeing space because it's black, right? I don't know what you call that.
No, because if there were no objects, you would not see anything. You would say, I see black. But what do you see?
I'm blind. I see space. No, Bobby, you're blind.
You're not seeing. What you see is the moon. You see Jupiter, and you say, well, here's the moon, here's Jupiter. What's in between, we'll call it space. That black stuff.
I see space. No, you're blind, but... That's it. That was it.
Okay, we'll see you with that next.
A lot of people talking about...
one more?
No. What was it? Calculating for mass in E equals MC squared. There was a huge debate here going on.
There's people involved with this E equals MC squared.
Love that one.
All I can tell you is I discussed E equals MC squared in the past and just synthesizing, so we don't stretch it that much. Energy is a concept, mass is a concept, and little c is also a concept. It's just the speed. Okay, so all we have is, in mathematics, all you have is concepts, and they're numbers followed by units. That's all we have there.
Well, you can't.
The question from a physical point of view, which is what we're interested in here, is what are we referring to when we talk about energy, mass, and velocity of light squared? How can we convert these in some physicality that we can all relate to, that we can all visualize. That's where we need the issue. And the, just again, to synthesize, I'm not going to go into all the details, but I'm saying that light travels from one atom to another and back again. In other words, the other atom also sends light to this atom because all atoms are interconnected. That's your C squared, because means light travels in both directions. And to every atom in the universe, and every atom in the universe sends light to our atom, our target atom here. And so that's the C squared. Mass, as I've shown in the past, is the mass of the hydrogen atom, because which is the minimum entity where you have something in the universe. That's the unit of mass, the hydrogen atom. Everything else springs from there. And so you have the hydrogen atom and the velocity of light squared. And if you can find the video there in somewhere, you'll find more details on that. But that's essentially our position.
I didn't realize until you just said it, but no matter what calculation you're doing in math, you're always using concepts.
Yeah.
You can't do math with objects. By definition, you're either using the length of the object, the speed of the object.
And it's not the length, it's the
color
measurement. The distance traveled by your tape.
You're always, it's always concepts. I never noticed
that. It's all concepts in math, and that's why, unless they put some physicality to it, it's irrelevant. But more important than that, the reason they had to give physical interpretations to that is that otherwise the math would be irrelevant.
Yeah, no one would care.
Nobody would care. Okay, folks, with that, we'll see you next week.
Thanks for tuning in.